Okay, let's take a look at our fourth example. That says a function f. This function here is defined by the polynomial. Uh, some values of x and fs are shown in the table. Generally, you know that for instance, if I say my function f of x is equal to some number ax cubed plus bs squared plus cs plus d, then this function can generally be, it can be represented like ax plus k, x minus p, x plus j. This function here is now represented in the factor form. So these are factors, right? That means if these are factors, what it means is ax plus k is equal to 0 is a factor. That means when I set x is equal to minus k over a, this whole function will be equal to 0. You see that? Because when I set x is equal to p here, this becomes 0, then the whole function becomes 0. So if you look at the question, you say which of the following must be a factor of f of x? For the function to be a factor of f of x, that means x minus 2 is a factor, means x is equal to 2. That means when I plug in x equal to 2 here, my f of x should be equal to 0. All right? So let's come back here. When x equal to 2, f of x equal to 1. That means it is not a factor. If it is not a factor, that means you get a remainder. In essence, when you plug in x is equal to 2, you get a remainder 1. When x equal to 0, you get a remainder of 3. When x equal to 2, you get 1. When x equal to 4, which means x minus 4 is equal to 0, means x is equal to 4. When I plug x equal to 4, I get 0. Since I get 0, that means x minus 4 here is a factor. And so if I write a function f of x, one of the factors will be like this. And then I can have a few more like that. So when you have a factor being part of a function, that means when you set that factor to be equal to 0, the resultant value of x, when plugged into the function x, will set the whole function to be equal to 0. And therefore, in this particular case, the one that satisfies this is C, because when we set s is equal to 4, we get f of s to be equal to 0. So that is kind of how you deal with functions and determine factors and non-factors. General non-factors will give you a remainder, and factors will not give you a remainder.